these days. He is the chief data scientist at Ascent Solution. He's holding a master's degree in computer science. So please join me to welcome the more than 15 years experience in the data science, Mr. Michal Siwek.
Good afternoon, everyone. Thank you for coming. I have this pleasure to spend next hour or next 30 minutes with you. I will talk about what do we define data science in business. I will introduce our company, how we work, because that kind of explains how we apply different data science methods with our customers and what we should look after. And I will share with you a couple different use cases. Hopefully those use cases will give you some kind of picture how data science, data visualization, data engineering is important and what we do with that. So this is a very brief agenda, starting with the introduction about the company. I will give some spotlights on the data science. We'll give you some example of data visualization, which then we can take to Q&A as well, like why data visualization is important. Then look at some use cases that we implement here in Saudi Arabia with our customers, and then talk a little bit about the data science experience program that we run at Ascent, like what we can offer, how it works with us, and what you can also learn with us going forward. So starting with Ascent, who we are. We are part of the Al Fuzan group. We are a solutions company that brings different solutions from outside to Saudi Arabia, or we are building those solutions ourselves. And those solutions can be digital solutions, data analytics solutions, or some kind of project program management solutions. We started as a healthcare company, Ascent Healthcare Solutions Company. So we focused on the healthcare industry, working with the hospitals, working with the Ministry of Health. We deployed one of the largest and one-of-a-kind command center in the world, which is managing the whole healthcare system here in Saudi Arabia. Looking at the hospitals, looking at the patient experience, looking at the different elements of the whole system. We were leading the COVID program during the pandemic, both mass testing as well as vaccination program, and we used the concept of data science in basically advising the stakeholders, the leadership of the Ministry of Health, what kind of decisions needs to be taken. We are led by a set of core values. The ones which are really relevant for data science will be the agility and responsiveness. So agility and transparency within agility being very responsive to the situation, it's kind of core. What data in business brings is the transparency, so the leaders can take information-driven, data-driven decisions, and they have backup information why they need to do something, why they are doing something. As a solution company, like I mentioned, we have a set of different alliances, both from the public sector as well as the private sector. We are working with a couple of the PIF companies, with like Elm, which you may know from Upshare application, or Lean, which you may know from the Sahati application. So we have really a strong partnership with multiple organizations here in Saudi. However, like I said, we are bringing solutions outside of the Saudi Arabia. So we are partnering with GE Healthcare, for the healthcare business. We are partnering with Orion, NSC, Barco, which is the biggest worldwide supplier of the video walls and then display technology solutions. But then we also cooperate with some private companies, like private hospitals like Humber River. Humber River is considered as the most digitalized hospital in the world, and it shows how data can support decisions in the hospital. We are divided into 5 verticals. The key for us today would be the Performance Plus and the Digital vertical. Digital vertical is responsible for developing and bringing the solutions, while Performance Plus team is responsible for implementing those solutions with the customers. So Performance Plus divides into advisory services, change management, business development, as well as the analytics team, which is focusing on the data science, data engineering, and data visualization. So each and every project that we are running right now consists element of the data science, and the data science team is supporting that. These are kind of our core capabilities. Like I said, we are focusing on the command center. The key element of the command center, which is like half of the success, is data. using the data, integrating the data, collecting it from different sources, putting into one set, and bringing different insights to that. And to bring those different insights, we use different data modeling, data techniques, and methods to get some deep insights and present them to our customers for decision making. And the other element is that we are using proven methodologies. We are following different frameworks like the COB framework, which allows us to first calibrate with our customers what we want to do, explore different options, explore different methods and techniques we should use, then build them, and then finally organize and realize them with the customers, which means implement them with the customer, and then hand it over back to the customer and build their own capabilities within their organization. As any kind of project, we are also following very strict life cycle for the project management, starting with like project initiations, defining the problem statement, and I will talk about problem statement a little bit more later. But then it goes to analyzing the risk issues, stakeholder management, communication management. It's like any kind of projects that you would run in any other area. But for data science, it's important. So we are clear upfront what we want to achieve, what kind of data we want to collect, and then what we want to do. So we want to define what's our end goal. So we are really structured in our approach. Usually the data science team, like data analytics team, data engineers, they will be very structured, a little bit introverted people. So they want to bring that into the project so they are clear what they want to do and how they want to operate. We are looking at 3 elements in our projects. First thing is get connected. It means get connected with stakeholders, get connected with the data, collect what information is available, what can we learn from the customers, what we can learn from the competitors of the customers. Second thing, it's about getting insights. So it's building the operational excellence. What we can find from the data, what we can find from integrating the data from different sources, so that the different teams, different data sources don't exist in the silos, but when we bring them together and we correlate them together, there are usually some additional information, additional insights that we can put on the table. And then finally, get optimized. And part of the get optimized will be knowledge sharing. It's basically to realize the project, to share the insights and start making the decision driven on the outcomes of the projects shown by the data analysis and different methods and applications that we manage to use. Now, if we focus about the data science, starting what kind of capabilities the data science can bring to the project. Right now, everyone talks about AI, machine learning, deep learning. All of that is kind of part of the advanced analytics. When we start our projects with our customers, we want to be clear that first what we want to do is just understanding what's the situation, like put the house in order. So very often we would start with the very simple methods like descriptive analysis, diagnostic analysis, and then move to more advanced things like machine learning, AI, or at the end, deep learning. If we don't fix the house, if we don't understand the current state of the organization, then applying advanced methods, which we cannot fully explain how they work, will be very difficult in decision making and then understanding what's happening and why we need to make those decisions. What is the data telling to us? So, like why it matters right now and what's causing the big hype on data science these days. First thing is that within the last 10 years, the software, the hardware and software that is available for data scientists, data analytics, data engineer has very much improved and the cost of it has decreased. Basically, this makes this more available to everyone and application of it is much more economically explainable. So it's much easier to use this method. The GPU is much more cheaper these days. We can build much faster models and create and use much more insights from the big data. The volume of the data that is being created today within the last couple of years, it's much larger than if we look at the entire history of the human beings. And every year, every 2 years, the volume is bigger and bigger. We are getting new algorithms. We are getting new methods which are used with the data. Like previously, we would look only at very simple descriptive analysis, starting with the simple regression models, logistical models. But today, in the deep learning with the neural networks, with the different kind of approaches, those approaches create much deeper insights because they can process much more data in much faster way. The cloud services that are available right now, this kind of comes with the hardware. It's much easier to use those cloud services. They are much cheaper. They allow us to process the data much faster, and therefore it makes much more economical sense as well. And then finally, increase investment in the activities. So today, everyone is trying to do something around AI machine learning. If someone is not doing, then they will be left behind, and then at some point, they may make no more sense economically. So basically, they may disappear from the market. They may not be able to function on the market. So every kind of company, whatever they do, even if the operating model, the operations, it's not really related to the data, they still use different data science methods, data science approaches to manage the operations. And this can be about the workforce planning, capacity planning, the size of the organization, the future of the organization. And even using some like the latest technological innovations like ChatGPT-3. ChatGPT-3 can now tell us what could be our next client, what we should talk to our client. So using this data science method allows the business to survive, but also to develop and look at the other new areas of their focus. This graph is just showing how AI is being developed and how rapidly it's expanding. Today, like for example, with the social media data and the volume of the data being created in social medias like Twitter with the text data, but then also TikTok or Snapchat, the data is huge. And then not utilizing this data, monetizing and taking advantage of the data, we are just losing the competitive advantage what the organization could do. Social media very often provides lots of insights about the customer experience, citizen experience, or patient experience in the hospital. Then utilizing this data allows the operator, the organization, to respond and cooperate with the citizens. That builds this interaction that we didn't have in the past, which we can be more citizen, customer-oriented, and provide the services that the customers are looking. And I assume many of you are using different kind of online shops like Amazon, for example. And very often using those shops, you will receive directed to you advertisements of different products. And basically, this is the result of the data science. Like the next product to buy methods, they are showing what's the probability for you to buy specific products. It may be from the specific category, it may be for a specific brand, but basically everything is being oriented on the customer, and it's a customer-oriented marketing plan. So you can see it on a daily basis in your phone or your computer, and you may not fully rely on what kind of methods, techniques are used behind that. Now, what is it? I already briefly described how we define data science, what are the different elements. If we use like a very simple breakdown, we can say the first part of the data science will be to describe. So answer a question, what happened in the past and why it has happened. It could be part of the root cause analysis. It would be basically some kind of trend analysis showing how the past have looked like. And this is kind of the starting point, understanding what's the current situation, how did we perform in the past. The next level would be prediction and answering a question, what would happen in the future? And what are the different elements that are influencing the future? So what are the different correlation between variables, indicators that create our future so we can predict the future and the decisions of the citizens that they can take. Then finally, the third element, the third level would be prescriptive analytics. And so it's answering the question, what should be done to influence the future? So these are the different types of the simulations that organizations are doing to simulate the behavior. We can simulate the citizen behavior. So this next product to buy is kind of simulation. It's simulating what would be the next product that you're very probable to buy on Amazon, for example. So there is a high chance. That's why it's a targeted marketing. If we got a little bit more detailed, especially for the first phase, like I said earlier, that usually we should start with setting up the house right. We could split the descriptive analytics a little bit more, starting with the analytics maturity. And this is the key for the organization, especially the organization which never looked at the data, never really cared about data collection, never really looked after the quality of the information that they are collecting and kind of systems they operate, and if those systems are integrated with each other or not. And this is kind of the role that Ascent is playing, looking what's happening in more developed countries in the West, using the digital solutions for many years and bringing them here into Saudi. Like, for example, Saudi healthcare, it's really down the line in terms of implementations of the digital solution. Here still we have many hospitals which collect the data on the paper, not in a digital form. The only mature organizations that we see here in the kingdom would be the banks or the telecoms, which have to collect the data in the right way because that data is usually directly accessible by the customers. So the customers always see the data and they actually control the data. If the end user, like a customer, citizen, patient, don't control the data, then the organizations very often don't really care about the quality of the data. So that's why we start with the analytics maturity, data maturity. That basically defines the next steps, what we should focus on. Can we move into more advanced methods, predictive, prescriptive, or first we should look at the descriptive analysis, describe the current situation, and build a plan what we should do first to manage the current situation. Next thing would be descriptive analytics, so that's what I described earlier. But then it's a diagnostic analytics. And diagnostic analytics, it's all about the root cause analysis, understanding why something has happened and what has impact on that. And this basically helps into planning, because then we can understand if the systems that are collecting the data are fault, or if the customers which are using the data are inserting the data in a wrong way. So therefore, we can improve that, make the data collection system more bulletproof, so then the data quality improves, and then we can use it for more advanced use cases. This one is showing just the correlation between advancing the solutions and then how we can get different insights. Obviously, today we are more into the left-hand side of the diagram, where we look more into standard reporting, creating reports rather than recommendations or predictions, prescriptions. But however, everyone is trying to move to the right-hand side. So looking at the forecasting and optimizations of the processes, optimizations of the behavior of the customers. And that leads to utilize more advanced methods, more advanced techniques. Now, how it works, that should be the most interesting part. So how it works, first thing is what are the different skills, how the typical data science team is broken down. We have different team members. We can have statisticians, we can have computer scientists. However, the background of the people doesn't really matter. What matters is the interest and the spike into numbers. If someone is interested in the numbers, can really become a data scientist and data engineer. In our team at Ascent, we have people who are dentists, but they have a spike in the numbers, and they started the data science career. We have people who were software engineers, who were really hard coding in languages like C, C++, but they actually wanted to work on a different level, looking into business use cases, be more responsive, more talking to the clients, and this kind of data science tracks allows them to do that. So what we have in the center is the analytics leadership's kind of analytics translator in between. So the role of that person is to be kind of communicator between business and then technical team. So sometimes the technical team, like I said earlier, introverted approach, the language that they will speak will not be understandable in English or the business English. So we use that translator role to understand the business requirements, translate them to analytical data science requirements, and then altogether we can build a solution. So in the data science, we really have a mix of different competencies and everyone working together to deliver the best outcome, the best solution for the customer. We are following very structured framework, very structured process. This is, like I said earlier as well, is just to be clear what we want to achieve from first moment, and then follow those steps so we can on timely manner deliver. It's a loop, so whatever we define at the beginning may change over time because of the data availability, because of the priorities or something else, but it's still important to follow a couple steps so we are very well organized. And that will basically will start with defining the problem statement. On every project, consulting project, advisory project that we start, first thing we do is defining the problem statement. It should be smart, so it should be very specific, measurable, actionable, and relevant for the organization. So we want to make sure that we will be able to solve that problem within the given time frame, and we will have all the relevant resources. So then we are structuring the problem, understanding what are the different stakeholders that will take part, what is the different data sources that we need, what would be the different methods that we're gonna use. Analyzing, this is where the data science comes to the play, analyzing the data, putting different graphs together, putting different analysis together, and sharing them with the broad team. And finally, the step is called synthesize. It means share the results with the stakeholders and start implementing them in the organization. Then this is where the loop continues. If the solutions that we work on doesn't really work, either we need to adjust the problem statement a little bit, or we need to go back to the structuring of the problem step to collect more data, to find the different stakeholders, to learn something more that we didn't know in the first step. Like I said as well, it's a following very specific framework. The key is like to define and identify the challenge, scope it properly with the right stakeholders. We always want to make sure that we have everyone in the room. This works really well in the command center concept, where our requirement for the command center is to have everyone in one room working all together. So we never want to work in the silos. We want everyone to share their opinion, their knowledge, what they know about the problem, what they know about the data, what they know about the processes, so we can put all of that together to find the best solution to what we are working on. The different steps that we follow in the data scientist work, starting with the capturing the data, capturing any information relevant for the project, going through the process may be about how we're going to pipeline the data, what kind of different steps we're going to take to capture the data, something about the data governance, which is relevant, what kind of data we can access, that we don't breach data governance, where we will store the data. The next step will be storing the data itself. So where are we going to store it? If it's confidential data, for example, it shouldn't never leave the boundaries of the country. So it should be stored and processed here in Saudi when we talk about healthcare data, banking data, for example. Then analyzing the data, applying different methods, like I said, descriptive, predictive, prescriptive methods, and then starting utilizing the data with the stakeholders and with the customer. This is like a high-level view how the approach could look like for data-driven, technology-driven organization. And here, when we talk about the data science team, we sometimes could call them wizards. The reason for that would be that very often no one else knows what those people are doing and what kind of techniques they are using. And even when we talk about AI or specifically deep learning, the deep learning techniques are like black box that no one really can explain why the black box took specific decision. So one of the first deep learning techniques was the neural networks. It's to mimic how the human brain is working, and no one really can explain why the decision was taken that way. So that's why it's kind of a bit of magic, putting different things together and then sharing the final outcome to that. On both sides here, I showed this translator role. So first is to collect the right requirements from the stakeholders, from the business. But then on the other side would be to share what the data science team has found in the data, how they presented the data, and explain that to the customers in a way that they can start driving decisions and utilize that information. Like the key here is that if the data science team do something for business and then the business is not using that information, it's actually lost time, lost investment. So we need to have that close cooperations with the stakeholders and the business. Otherwise, the work is just a state of the art, but it's not used for anything, basically. If we look at the different steps of the journey, it may start with capturing insights. It's a basic insights from the descriptive analysis, for example, like what were the trends, what was the situation, what were the different root causes, what has happened in the future. Then the key would be to start capturing the value. Capturing the value means what kind of interventions, actions we are doing from this data, how we are monetizing this data, how we are making sure that the data is part of the organization DNA, and therefore we can really be a data-driven organization. Then getting to the scale, very often we start with one department in our organization, but then start moving to other departments, showing them what's the value. And then we are also making sure that the departments are working together. So one department can be supporting the other. Like the finance department can easily support the supply chain department in improving the processes and optimizing the operations of the organization. And then becoming a fully driven, analytical, data information-driven organization. And this kind of may lead that one day AI may literally take over control of the organization, can be taking all of the decisions. Like today, we are talking about self-driving cars, right? So we already see it. In California, there are already many different organizations which are deploying, and those cars are on the streets. They are self-driving, fully autonomous cars. So the AI algorithms, data science algorithms, are taking all decisions that this item, this car, needs to take to be part of our ecosystem, of part of our life. So one day, this can come to the business. Like right now, we are talking about different elements of our processes on our organization. So even something like consulting work, advisory work, at some point can be replaced by AI, by ChatGPT-4, ChatGPT-5, whatever comes next. Even writing essays can be covered by that, right? That's a big challenge for students, big challenge for the university faculties, like how we can control all of that and then input of that. That also comes to the ethics of the data science and AI. That's a totally broad topic. What kind of ethics we should be looking after in terms of data science in business, especially when it comes to AI and deep learning. I briefly said before about the command center concept, and here I would like to say a little bit more what it is and how we define it. Basically, the goal of command center for us, and then using command center with data science and business, is to put the different organization in one room. It's like a working room where everyone knows what's their role and everyone brings something to that room. We define the problem statement all together. We bring the right data, we bring the right decision makers, and all of them solve the problem and make sure that the solution for the problem will be sustainable and will change the system, change the behavior of the system. So the command centers can be for anything. The command center can be for healthcare. The command centers right now we would have at the airports, which are controlling the airport traffic. The command center can be at the university and be supporting, for example, the scholarships for the students. So it's about the concept. The concept is about bringing the data methods, bringing the people, bringing the decision makers, giving them information, giving them insights, and then supporting them on the daily basis. This is kind of describing what kind of decisions can be made in this command center, like how data science could support the business. It can be very operational. It can be supporting the decision right now, right here. So like at the airport, the traffic control, the data that they are receiving from the planes, the reaction is right now, right here. When we go to the bank and we are asking for a bank loan, very often we get the answer what kind of credit score we have. It's kind of right now, right here. So these are very operational use cases. And all of that are data-driven. They look at the history of our performance, what we have done, what we haven't done, and then supporting the person in the bank, the person at the airport, the person in the hospital, with what kind of decision, what kind of action they should have made with the specific customer, specific citizen or patient. But it can go into long-term decisions as well, long-term support. And here we can have the example of the capacity planning. I will show some examples of data visualization which are really good for that. But for example, we can understand where should be the next hospital be open and how big that hospital should be. Or they should be as simple, where should be the next ATM open? Where do we have traffic of people which are using ATM and where we should locate that ATM? So that's a very typical use case for the banking. When it comes to the, for example, restaurants, where we should open the next McDonald's. All of that information is not just random. It's based on the data. There's lots of volume of the data, like the population density, the demographic of the population, which are driving those decisions, the long-term strategical decision, how we can make our business optimized, and then data-driven. One slogan that we are using very often in our business and discussions with the translator is basically keep calm and let the data scientist, data analytics person do the job. The reason for that is that it takes time. So we cannot do quick decisions very quickly. We want to take time to understand the data, understand what methods needs to be taken, which are the methods are the best for the specific use case, and therefore what would be the best insights that we can generate for our stakeholders. Now, when it comes to data visualization, I would like to share a couple of examples of data visualization. Two of them are actually considered as the top 10 best visualization in the world that have been ever made. They are very simple, but we will get to that point. However, this illustration shows what's typically visible to the stakeholders, to our business partners, versus the work that needs to be done behind the scene by the data science, data engineering team. So a lot of that, it's about understanding the data, processing, integrating the data. Usually the ratio is something like 80-20. So 80% of the work is the backend work, while the 20% work would be the visible work to the stakeholders. So they would be about the data visualization, the reports that the stakeholders see, and any kind of physical outcomes of the work. So when it comes to the visualization, I'm not sure if you know this visualization. It's a very famous visualization from 1854. So it's almost 200 years old. This visualization gave some additional insights to the business that the people who were analyzing the data couldn't really make aware of that. It's a GIS type of the visualization, so showing some specific event on the map. It's showing the outbreak of the cholera in London in the 19th century. And when the data of cholera was put on the map, they were trying to understand why in this specific quadrant on the map, there are so many different infections of the cholera disease. And when they put the data on the map and the cases on the map, they have realized that next to that quadrant, there is a water pump. And the water pump was contaminated with cholera. So that allowed them to understand what is the root cause for so many infections in that area. So the cholera, like the bacteria, was in that pump, in that water well. People were drinking the water and then therefore got infected. They also noticed that 2 blocks next, there was a kind of brewery, which they have their own water supply. And they didn't notice any kind of cholera outbreak over there. It was because that well in that brewery was clear, it was a clear water. So presenting the data on a map, for example, and the GIS analysis are very popular right now, helps to create some additional insights and then decision makers to speed up the decisions and make more information-driven actions. This is another example of visualization of the data. It's also considered as one of the top 10 visualizations ever. This is actually showing the Napoleon campaign when Napoleon was moving to Russia, to Moscow. And basically, this visualization is showing the whole story of that campaign. It's showing when Napoleon started the campaign, how he moved from France to Russia, and then when he was returning, what has happened with his troops. So there are a couple principles when we talk about the data visualization. And these two examples basically are fulfilling all of them. If I will start from the second principle, which is storytelling, we are making sure that all of our visualizations that we are making, how we are presenting the results from data engineers, data visualization specialists to the business, is telling a story. It's compiling. And this story needs to be clear. It shouldn't demand any additional effort to understand the story, and therefore be very straightforward to it. The information shared on the visualization should be very clear, color-coded, using very specific requirements with the legend, description of that legend. It should have specific goal. So like the second visualization I showed you, the goal was to tell the story of the campaign. So each of the visualization, it's like I said earlier, it shouldn't be just a state-of-the-art visualization. It needs to have a goal with the audience, with our customers, with the business that we are working with. And the final one is the visual form. So that's kind of combined with all the other ones. The visual form needs to be clear, following very specific standards. If we are showing trends, typically it would be a line chart. If we are showing some like totals, it could be a bar chart. Very often we are saying we shouldn't use like donut charts or pie charts. It's not sometimes acceptable. But every kind of visualization should have the proper purpose. It should be presented. This is the way how we are actually selling our work. This is the visible form of what the data science team is doing. A couple of use cases that we are working with our customers here in Saudi. So the first one is very much correlated to what I was saying about the hype about the GIS analysis, the Geo Information System analysis. This one is showing the population density here in Riyadh. And the road that is showing some kind of specific services. In this case, it's actually the healthcare providers here in Riyadh. So we were trying to understand where is the demand for the new primary care services or urgent care services. So this analysis could show us a couple blind spots where we have high population density. However, we don't have any healthcare provider nearby. So this is kind of goal objective for any kind of city leadership, city management, to make sure that the citizens have access to the services in a very close proximity. The additional good information here was that lots of those blind spots are actually close to the ring road. So opening new care services over there would actually open access to those services to quite large number of potential patients, potential citizens. But this kind of analysis can be applied to any other. Like I said, where the next McDonald's should be opened. That's kind of the same principle. Where the next ATM should be opened for a bank. Like where we have a blind spot on the map, where, for example, there could be the demand for the ATM machines. It's the same exact principle that everyone is using wherever they want to open a new locations or new center. Another example of the correlation matrix. This is also a real example of looking at the weather and, in this case, health services. In this case, we were looking what's the impact of the sandstorm of the patients coming to emergency room. How can we prepare the emergency room? How we can prepare the hospital so it's ready for more patients coming to the hospital. It's looking at the only very specific time period and only one region, so the correlations are not strong. However, this is showing the concept of using a bit more advanced method than just descriptive, looking at the correlation between different factors, and therefore start creating additional interesting insights. I was working, for example, on a project for a pipeline for an oil company, not here in the region, in a different region, where we are looking at when the oil is being stolen from the pipeline and what are the different indicators which are correlating with it. And what was correlating there was actually the moon phase. The no moon, the number of the stolen oil was higher because it was dark, no one could see the people. In a full moon, there were no such incidents. So sometimes there would be very non-obvious correlations which can really generate interesting insights. So here the key is to be very agile, very open, look out of the box and look at the different sets, not only this data that is available for the organization, but also broad data that is available on the market. Another example, this is an example of the deep learning. I'm sorry, I have a lot of examples from the healthcare, but like I said earlier, we used to be healthcare solutions company. But healthcare is very interesting in terms of data because there is a lot of data which is not being utilized in the right way, which can really create a lot of impact. This is an example of a deep learning method and understanding the chest X-ray and supporting the doctors in making the faster decision. And it's already proven that AI machine learning methods can make the decisions faster and actually better decisions than the doctors. So the doctors can really be supported by the data science in their daily work. It's not to replace the doctors. The doctors at the end always will have the final decision what kind of treatment should be applied to the doctor, to the patient. But it's really to support them on daily basis to provide the best care to the patient. And another example about the social media, how we can use information from social media to understand the performance of our organization. And this is example of Ministry of Health, what kind of information the citizens or patients are sharing about the Ministry of Health, and how we can react in case of any kind of crisis. This crisis could be around lockdown, which the Ministry of Health was part of, or it could be about the vaccinations and the demand for vaccinations, availability of the medications. We are just before the flu season, so there will be a lot of expectations about the flu medications. And then citizens may complain about that. And typically citizens will complain about that in social media. So social media for us is kind of early warning platform before a storm happens. So utilizing this data in the right way supports the business, supports the decision making to be way more proactive in the decision rather than just reactive. So 1 or 2 complaints can support us to reacting in a proactive way to provide the right supply, or at least provide some response to the public so we don't wait for more people to complain. I would like to briefly talk about the Data Science Experience Program. So it's a program that we are running at Ascent. It's a program addressed to graduates or last year students that are really interested into data science, not just from the technical perspective, but even from this translator role, how we can use data science in our daily work to support the customers. So we are running a program addressed to anyone. It's a program for 18 months. I will jump back and forward on some slides. It's an 18 months program which allows the students or graduates to learn about different data science techniques and how they are being implemented in the business. It's a hands-on program, so the students, the graduates are becoming part of Ascent, and therefore they are being staffed on the real projects. So they are part of the team with a buddy from the more experienced team, with a specific program trainings, like on a weekly basis. Some of them are bi-weekly, to catch up on different topics or catch up on something interesting. Like I said, it's hands-on program with a coaching, training, and mentoring element. So no one is really left alone. There is always someone behind. There is a whole team behind and a whole advisory team behind, supporting how to use the information, how to use the data with our customers. There are some specific requirements which we can share later on as well. The key is to have a spike and interest in data science. I strongly believe if someone knows how to put the numbers together, how to read the numbers, it's really interested in data science, can do something about that and can use it. Like on daily basis, we really use data science at the small scale. So in the advisory services, we can use it really in a higher scale. Part of the program is not just technical skills, it's also soft skills. And we call it also meta skills. So it's kind of how we can be mindful about ourselves, how we can take care of ourselves, how we can take care of our development. In terms of the soft skills, it's definitely about the communication skills, how we can communicate the findings with the customers, how we can communicate them with our internal team, and how we can use all of that. So it's a kind of end-to-end program, how to move from the academic to business, how we can use things that we have learned in academia to real life. If we need to fill some gaps, this program supports us to fill those gaps and learn from the others who already have experience. Technically, it's looking at the very broad spectrum, starting, like I said, from the descriptive analytics, going through some elements of the predictive and prescriptive elements. All depends usually from the customers that we are working on, because these are real life projects that we are as Ascent or our partners are running. So whatever requirements are from the customers, we are fulfilling, and they're a part of this data science experience program as well. We are typically focusing on the 3 roles in the data science team. One is about the platform engineers and architects. This is more like a high level, more conceptual, how we can define the data, how we can define the structure of the program, how we should collect the data. Second one is about data engineering. So this is very technical, so how we can code the data, how we can build database. And the final one is about data science and data visualization. And really, in terms of the data visualization, I strongly believe that anyone who has interest in design could really become data visualization specialist. We are using very specific platforms, so that gives you all the tools, all the platforms that you need to do your daily job. Learn you how to do visualizations, how to build dashboards, how to visualize the data. And then on top of that, but that's kind of cherry on the top, we are also working with the other universities. We started cooperating with the Virginia Tech University for the same, how we can do some projects together, how we can do some kind of internships between students and Ascend and our customers here in Saudi. So I will close on that. We have a couple minutes for the Q&A or some kind of discussions if you have those questions. So if there are no questions, whoever also will be interested, these are the two ways how you can reach out to us. If you're interested in things like internships, running some projects, or more details about what we do, here's our general email and my email directly.
Thank you so much, Mr. Michal. Thank you all for coming, and a big thanks. A big thanks to our ex-colleague and our friends, Ms. Iman Benyamin, who used to be the College of Business undergraduate office manager. So please shake hands. So thank you all for coming. If no questions, free to go. Thank you so much.